Hi, chemistry students. This is Mr. Ferguson.
And Mr. Hunter.
And we're going to continue our lesson on dealing with ionic compounds. And today we're going to introduce polyatomic ions.
All right, our first objective is to recognize, and did we already say that one? Recognize and define polyatomic ions. And
no, we didn't say that yet,
okay.
so that was good. And then we're going to show you how to write formulas and give names to ionic compounds when they contain one or more polyatomic ions.
Alrighty.
So, first of all, what is a polyatomic ion?
Well, the polyatomic ions are a group of covalently bonded atoms with an overall charge, either positive or negative.
So it's a molecule.
Mm-hmm.
We haven't really covered covalent bonding yet, but this is a group of atoms that are stuck together. They're sharing some of their electrons, but they also have either more electrons than they have protons or less electrons, so they have an overall net positive or negative charge. So,
all right. So two examples of these. The first one is hydroxide. You just have to learn this one. It is OH. It's an oxygen connected to a hydrogen with a negative one charge.
Oxygen is going to share electrons with hydrogen, and oxygen we know has, this is a Lewis diagram.
Which we haven't covered yet.
But oxygen already brings 6 electrons to the party.
6.
And 6 outer shell electrons. Hydrogen brings 1, which adds up to 7. But you notice the way I drew it, I have 8. Mm-hmm. And that's because basically this thing needs one more electron and it'll be a stable arrangement. So it actually forms this little molecule of an oxygen bonded to hydrogen, and by grabbing that extra electron, it satisfies the octet rule, stable. So how we would write that on paper then, if we don't typically do the Lewis structures, we would write OH minus or OH minus 1 if you prefer.
All right.
So that's how we're going to represent that.
All right, and the next one we have up here is a phosphate polyatomic. That would be, we're not going to do the Lewis dot for this one, I don't think.
That would be
PO4. And then it's phosphate, so it's minus 3. It has 3 extra electrons than it should have otherwise.
Now, the thing about these is there's a number of them that are common. First of all, the only one that's common, though, that's positive is ammonium, this guy right here. The rest of them are all negative. And basically, they're not that hard to deal with. You're going to treat them just like you would any other ion when you write the formulas and when you name them, with just like one little addition, which we're going to cover on the next page. So you just have to, the hardest thing I think is to remember what the formula and charge is for each one, and then dealing with them is pretty easy after that.
Alrighty, let's take some examples. Alright, so the first example we have is that you first of all have to use parentheses anytime you're using polyatomics. You don't want those subscripts to be flip-flopped when you do your crisscross method. So first example of this would be ammonium phosphide. Well, ammonium is NH4+. And
so how did you know that, Mr. Hunter?
I just memorized it.
And
then phosphide is P minus 3.
So we're just going to do just like we would with any other of these. We're going to write the ions and their charges, and we're going to crisscross the charges. Now here's where the parentheses things comes into play. The crisscross is telling us we need 3 ammoniums, don't we?
Mm-hmm. So that would be parenthesis NH4.
We never ever alter the subscripts or formula of the ion itself.
Yep, you treat
put
those
in parentheses and then put the
charge at the bottom.
The subscript on the outside. So that's saying 3 of everything inside there.
It's not NH12 either. So then it's lastly then P1 because the charge of ammonia is 1.
So we'll just let it NH4.
Right, the next one is calcium hydroxide. So that's Ca2+. Hydroxide is when you have to memorize as OH minus. So parentheses around hydroxide make it Ca OH parenthesis OH2. And then the last one is magnesium sulfate. Magnesium is Mg.
With a
plus 2
charge.
Sulfate is SO4 minus. And then crisscross, so it's Mg, SO4, the 2's reduce, and no parentheses.
Yeah, if we're not going to add an additional subscript outside, we don't need the parentheses.
Exactly. All right, let's go on to the next. All right.
So naming these guys is really quite simple. You just have to recognize the ions that you're dealing with, and you name the cation first, you name the anion just like for any other ionic compound.
Exactly.
So the first one we have Li3PO4.
That would be lithium phosphate. And you just have to know that lithium is lithium and that PO4 is indeed phosphate. I don't think we've talked about this yet, but if it was a transition metal, you'd have to take into account a Roman numeral, but thank goodness we're not
deal
there
with that
yet.
in the next lesson.
Yep.
All right.
So the next one is NH4, which we know to be ammonium, and CO3 we know to be carbonate. So simply ammonium carbonate.
That one has 2 polyatomic
Yep.
ions in
It's
it.
very possible that can happen.
All right, so we're going to lead you to your post-video questions, see what you can do with this for a little practice.
So here are your PVQs. First of all, what is the name and formula of the only common polyatomic cation? So the only positive one. And then write the formula of ammonium nitrate. Okay, good luck.
See you next time.